Right guys, RC addicts, this 4-minute, maybe 5-minute video is going to tell you everything you need to know about dynamic idle and everything that the other videos don't tell you. Outside influences, the wind on the propellers, the resistance, active braking, negative torque, freewheeling, the windmill effect. Ever heard of that one? And the difference between active and static. It's all in there. Anyway, after this dramatic intro, here we go.
BETAFLIGHT 25.12 Dynamic Idle. The full explanation in 4 minutes by RC Addict. Uprush of air, dynamic idle active braking.
The first part of the illustration illustrates a high gravity flat drop, as you've just seen in the intro with my drone. Dynamic idle is fighting a thing called upwash. In a static idle situation, the uprush of air might spin the motors faster than the flight controller actually wants it to.
This is called the windmill effect.
Ultimately, this leads to loss of authority and a desync. Most probably just prop wash. When you activate dynamic idle, it detects these forces and forces the motors to apply counter torque, as shown in the illustration by the small red arrows. The motors are actively fighting the air to slow down the propellers against the oncoming rush of air. This maintains the precise RPM set by dynamic idle. And if you look at this up there, that is what BETAFLIGHT recommends for dynamic idle settings for the prop size. Don't be scared to try it out. I've set it 45, as you've seen in the intro, for a 3.5 inch drone with 2.5 pitch props, and it seems to handle it beautifully. There's no prop wash. But it is one of them settings that you just have to trial and error to get it right. Get your tune right, and then if you've got a little bit of prop wash and you know you have low pitch props or high pitch props, go by this chart. I have a whoop that's like 67, yeah, 6,700 RPM, and I have a 5-inch drone that's set at 3,500, which is the default, and which, when you apply a preset, pretty much everyone's going to put 3,500 RPM on it, and this may work.
Prop stall and reversal. From high speed 180-degree reverse moves, dynamic idle, rapid re-engagement.
So, we've talked about the windmill effect and overspinning the props. Now it's time to talk about the other way, so reversing the props. So a 180 reversal at high speed, get that prop wash, and what's actually happening is the air is pulling up like in the diagram, well, kind of like in the diagram because it's not exactly accurate, but pulling up into the props, and instead of trying to spin them faster, it's actually trying to slow them down or turn them in the opposite direction. In this, dynamic idle has to activate really quickly and apply re-engagement. Just quickly to mention that obviously dynamic idle is set when RPM filtering is on, right? And that's what most people have nowadays. So you'll select a preset and it will say, do you want RPM filtering? RPM filtering comes on and it gives you a default of 35 or 3500 RPM. The thing is that that's not the setting for all drones. What happens is the flight controller is telling the ESC, so through them tiny little wires at the front or at the back, depending on how you've mounted it, it's giving it a PWM signal, and basically it's telling the ESCs then to tell the AC motor. It's not a DC motor, don't get confused, the terminology is wrong. Calling it a DC motor is calling it the whole kind of configuration with the speed controller and the motor. But obviously the motor's got 3 wires, so it's really a 3-phase motor, a 3-phase AC motor. But in a whole package, with the ESC, it's actually called a DC motor. Well, I wasn't sure if I got the AC thing exactly right, but I asked Gemini and she replied this.
You have hit on one of the most common points of confusion in electrical engineering. You are technically correct. The internal physics of the motor are AC, but the DC in the name refers to how the system behaves from the perspective of the power source. The DC label, the DC part of the name, is a legacy of how the motor is controlled and its performance characteristics. It is called a brushless DC motor because, as you noted, the whole package, the electronic speed controller plus the motor, takes a steady DC voltage from a battery or power supply. A BLDC motor behaves almost exactly like a traditional brush DC motor. The speed is directly proportional to the voltage applied, and the torque is proportional to the current. Asterisk electronic commutation. In a brushed motor, a mechanical switch, the brush, flips the current. In a BLDC motor, the speed controller, ESC, does this electronically because the ESC replaces the mechanical brushes but keeps the DC-like behavior. The name stuck.
But anyway, what happens is back EMF or electromotive force, electromagnetic force, depending on how you want to look at it, comes back right through and back up the bidirectional wires up to the flight controller and tells it its position. And that's how dynamic idle works. It knows the position of the motor at all times. So anyway, I'm all bunged up. I felt ill for ages now, you've probably noticed in the video, but anyway, I hope that's enough information. It pretty much tells a lot, so thank you very much, and I hope you watched it all. If you did, put a comment down below and ask any questions, and take care, and stop looking at that fucking cooker, alright? Take care, I'll see you.